Okay, so we're going to finish the last two problems. So, remember, the directions are find dy dx, find the derivative. So, I notice there's a couple things. First, I need to use the chain rule. So, what's the first thing I need to do?
Move it in front.
Move the negative 1/3 in front. Perfect. I don't know where I put my pen. Oh.
Would it be negative 4/3?
For what?
The power?
Yeah, and then you move on the bottom. So y prime, chain rule. Move this to the front. So I have negative 1/3 times 3 times 2x and negative 1/2 plus 1. And remember, we must now subtract 1. Negative 1/3 minus 1 is negative 1/3, also known as negative 4/3. Okay, this was the outer. Now I need to take the derivative of this inner part.
And multiply by the whole thing.
I'm going to multiply by the whole inner.
Okay. Negative 1x. It looks like it's like 3/2.
So let's see. So I have to multiply by negative 1/2 times 2 times x to the negative 3/2.
Wait, how much else do we get?
So I'm gonna go over the practice quiz after this, which you don't get a calculator for. Is there a portion?
No calculator on the practice.
Yeah, you don't need it.
Wait, where's the? Wait, I have a question.
Yes.
The x on this when you do the inner, where does the x come from?
The
Like, you see
right here?
Shouldn't the x go away?
No, because it's.
Oh, because this is x to the negative
I
1/2.
see. I see.
Yeah.
Should it just be two?
It's negative 1/2, and every time you take the derivative, you subtract 1. So negative 1/2 minus 1 is
Negative 3/2.
Wait,
Well, I get that.
This-
But should it be 2 to the negative 3/2? Why does the x stay there?
Okay, so it's like 2 times square root of x.
Okay.
So
Oh, so if it was just
so I had,
if it was 2x, the derivative of 2x. And just
yes, if it was just 2x, it would just be 2. But because I have a different exponent.
Okay.
Yeah.
wait, so the parentheses you put around the x.
Is to show that the negative 1/2 is only being applied to the x,
But
not
that's
the 2.
another inner one.
No, that's not.
Okay.
I'm just trying to be clear,
Yeah,
like,
yeah.
okay, so I see the 3 and that goes away,
in the 2.
that goes away. Okay, so I have negative times negative, right? Because negative times negative is positive. But that's the same color. I wanted a different color. Okay, so this negative right here and this negative go away. So let me just rewrite this line so we see where we're at. So I have 2x to the negative 1/2 plus 1 to the negative 4/3 times x to the negative 3/2. Okay, now we can simplify that. Read my what?
Oh, okay. Yeah.
So now I can write this as, I probably should just finish this problem last time. Oh well. 1 over x to the 3/2 times 2, no, I'll just leave it as negative 1/2. 2 times x to the negative 1/2 plus 1 to the 4/3. Notice the negative of my exponents went away when I put it on the bottom of the fraction.
So if it's inside the parentheses, it would just be negative.
Yeah, because I wanted the outsider exponent to be positive. So,
Would you wanted us to like?
so the first,
To,
so not the part I circled, but the other purple line you didn't need. Literally, the only 2 things you needed to show work is this line and that line. Was that your question? No.
Do you want us to like make it simplify the x to the 3/2?
Well, the x to 3/2, you'd have to put it inside the, let's see, cube root of 2x and negative 1/2 plus 1 to the 4th power.
Okay.
Yeah, it would be different if it was like x plus 1, right? You just like distribute it out, right? But because I have this nasty, this is good.
Okay.
So ideally, you know when to stop, when what you would do is make it more complicated. You look like you belong in Whoville. There's grapes?
No, it's the ring around the drink.
Okay. Cool. Okay. You know when to stop. You know when to stop because if it stops simplifying, starts making your math harder, like going out. Because we did what we're supposed to do. We found a derivative, and we simplified it. What?
I think it's better to stop simplifying.
I mean, I have an answer, right? And when you're like, okay, should I distribute it out? It's gonna make it a lot more complicated. Because we did what we were meant to do. We followed the directions. We found the derivative. Went through all the rules. Simplified the negative. What? Did you just see her face?
Yeah.
This is what I was laughing at. Okay.
Oh my god.
That's a face. That's a face. Okay. So let's rewrite this top one out. Let's rewrite this. So I'm going to write this as x times x squared plus 1 to the negative 1/2. And so the whole dealio for this page is like rational powers of x. What if I don't just have nice numbers? What if I have fractions? Okay.
When you do the first derivative, and you do the outside, do you do the x and the negative 1/2 at the same time?
When I do the first derivative.
So
notice I have a x times this function. I have a function times a function. I have to use the
chain rule.
product rule. Being multiplied. It's a product.
No, we don't.
Yeah, it's a product of two functions.
Telling the teacher
But you couldn't do it the same way.
Wait,
Like,
no, but
you
so
couldn't-
If I hadn't done this problem before and like I didn't sleep at all, then I'd be like, you know, Maya, you're right.
Wait, really quick question.
Yeah.
If we look over at C, how come that's the
Wait.
chain rule?
Because you want a derivative.
Okay.
The first one.
Because there's no x out here. If this was 3x, that'd be a different question.
Really?
Well, because 3x is a function.
Oh my god. Well, and I thought I did the whole problem.
If there was a 3x right here, I would have to use product rule.
Oh, UV 1 plus
Yeah.
VU 1. Wait, and
Yep.
then do you have to use the chain rule? Or
I have to use chain rule for the derivative of v. So let me, what I try to do is like break the problem down and try to simplify it for myself so I don't like get in my own way. So first, I rewrote it so it's all in one line. I see I'm having an x times x squared plus 1 to the negative 1/2 power. Okay, so two different functions. So first, I write, I'm going to figure out what my u is, what my v is, what my derivative of u is, and what my derivative of v is. Then I can just plug in and just like chug along. That'd be great. The hardest part is actually figuring out what these derivatives are. So u, I'm just going to have equal to my x, right? So of course, I'm just following the product rule. V is just going to be my x squared plus 1 to the negative 1/2. Okay, derivative of u. What is the derivative of x?
1.
1. Perfect. Look at that. That should be easy question for you. Do you guys ever just like pause and stop and think how much you've learned this year? No, you should. You should stop. You should think about that, and you should be like proud of yourself because this is not easy stuff. And the fact that you mostly haven't given up and you mostly haven't like fought me. You fought me a little, but like for the most part.
I yelled no at you.
It's forgivable. Forgivable. Showing up, showing out, like this is solid. Okay. This is the hardest part. Are we ready? Hardest part. Noah. Hardest part. V prime. I have to take the derivative.
Half times x squared plus 1 to the negative 3/6.
Called you out and you got it. Okay. You have to we have to use the power rule. So negative 1/2 times x squared plus 1 to the negative 3/2. And then
2x.
and derivative of the inside times 2x.
Wowie.
So if I wanted to rewrite this, this would just turn into negative x times x squared plus 1 to negative 3 halves. So the reason, what happened to my 1/2 and my 2?
They made negative.
Exactly. This part right here, the 2 and the 1/2 cancel out. Okay. Let's pause here. Yeah? Like, looking in your eyes. Like, this is the time to, like, switch it out and be like, nah. Okay. Okay. So now we just plug in. Now we just plug in. I'm just gonna just straight up plug in. Okay, so ready? Y prime is gonna be u x times v prime. Okay, so times negative x squared plus 1 to negative 3 halves. Okay, plus v times u prime times 1. So this is u v prime v u prime. Hopefully the little letters above, it just shows you I'm just plugging straight in. And now the rest of the problem is just simplifying. I have this long thing. I just need to, please don't choke on the plastic. Please don't die. Are you done? I can't tell if it's inside or not. Like, are you okay?
Yeah.
Were you like sucking inside? Okay, Kylie. Okay, so I have negative x squared times, let's see, x squared plus 1 to negative 3 halves plus x squared plus 1 to negative 1/2. So this is, okay, tricky part 1 was finding derivative of my v, right, using chain rule. Tricky part 2, the ultimate sequel is right now.
You can take.
What? Hold on, wait, don't say it. What can I factor? Think to yourself, all right? So we see we can factor in x squared plus 1, but what's what power? What power?
Negative 3 halves.
So I take negative x squared times, let's see, ooh, actually no, because that's only multiplied by the first one. So I need to pull out an x squared plus 1 to the negative 3 halves. Okay, if I pull out, hold on, if I pull out an x squared plus 1 to negative 3, 2, that guy goes away and I'm left with negative x squared. Okay, first part, okay?
No,
I don't understand
not
what
okay
you mean.
because I don't understand how you can put.
Yeah, why can you do that? I don't get how that, like.
3 halves.
So what is x squared plus 1 to negative 1/2 divided by x squared plus 1 to negative 3 halves? So what you do is you take negative 1/2 minus the bottom, which is negative 3 over 2, add it together, and you get 1. You get 2 over 2, which is 1. So literally, this just turns into x squared plus 1. Okay, hold on. Yeah, you say you don't get
You
it.
know that if we see negative 3 over 2 and negative 1/2, we pull out negative 3 over 2.
But what if I give you other fractions, like,
You don't want to do that.
what if I give you like negative 4 over 3 and negative 1/3? 100% I would do it. Why do you think I'm like saying this to you? If I wouldn't do it, I would just be like, oh, okay, Tall, that's a good idea. No, I want you to know how to do it.
Can you go over it one more time?
Yes. So, do I have more room? Let me scoot over here.
Wait, before you scoot.
Do you need this?
Yeah.
So I was going to, okay.
Wait, you can scoot in 3 seconds.
Okay. So I'm going to take it back to algebra. I'm going to take it back to algebra 1. Are you ready? Algebra 1. Distributing, you take something and multiply by each of them. Factoring is the opposite of distributing. You're pulling something out. What? I'm describing it to you.
No,
Never mind. I was.
Ah.
Yeah, I took it in 8th grade.
Yeah, that's
Okay. If I take x times, if I do x times x plus 1, you know how to distribute, and this would be x squared plus x. Okay, if I had something like 4x squared plus 16, you know how to pull out a factor of 4, right? Okay, now the tricky part is when you don't have integer exponents. What if I have something like, x to the third, let me do an easier one for you, plus x squared.
x squared plus.
So let me show you a process. Ready? Let me show you a process. So you see there's an x squared as part of them. Now, this is what I do with my intermediate children. Because they have a hard time understanding, like, well, what do I put here? So what I go through, and what will help you, what I'm trying to show you, is, okay, I'm going to pull out an x squared from each of these. X squared over x squared is 1. Then the x squared over, x to the third is just x. Okay. Now, we understand this process?
Yeah.
Because now I'm going to use it and show you how to do rational. All right, just really try not to let anyone be behind. Okay. Now let's have it be a harder question. How about x to the negative 4/3 plus 2x to the negative 1/3. So I know that both of these have an x in them. The question is, what do I pull out, right? What if I pull out an x to the negative 1/3?
You could do that.
If I pull out an x to negative 1/3, let's see, negative 4/3 minus a third. I'm using rules of exponents. Minus a third gives me x to the negative 1 plus 2. Okay, well this, I mean, it's okay, but I'm going to have like, x to the negative 1/3, and then inside is also a negative exponent. What if instead of pulling out a negative 1/3, what if I pull out the larger one, right? Pull out the larger one and let's see what happens. So I have x, sorry, I'm gonna change it so I'm dividing each of these by x to the negative 4/3. So you see this one goes away because it's the exact same thing. So I pull out an x to the negative 4/3 and I get 1 plus, and then the issue is negative 1/3 minus a negative 4/3, what?
Just x, right?
Yeah. Is equal to 3/3, which is 1. So then this gives me a positive exponent inside when I'm factoring it out, right? So it just,
What if we put the other one?
so you would prefer this way,
Yeah, prefer.
because
I don't.
in our right side, we have another term where like it will simplify inside. So you could try pulling out the larger one, right? So to more generalize and simplify Tall's rule, try pulling out, since if they have the same denominator, try pulling out the larger one, see what happens. So when I come over back to the right side, okay, I see I add to the negative 3/2 and the negative 1/2. So by pulling out the negative 3/2, right, this part in green is showing my rules of exponents, right? This x squared plus 1 is now to the first power, and now guess what? I can combine those. What is negative x squared plus x squared? They go away. And then I multiply this whole thing by 1, so it turns out my derivative is just 1 over x squared plus 1 to the 3/2. Yeah. So what is 0 plus 1? 1. And then multiply anything by 1 is itself. So this turns into x squared plus 1 to the negative 3/2 times 0 plus 1. Well, 0 plus 1 is just 1. 1 times anything is itself. Okay. So that was a good question. Yeah. Let's go over practice quiz. Now we're on chapter 3. Okay, the practice quiz is 11 questions long. I'm gonna try to make the quiz shorter. Definitely won't be longer than 11 though.
Definitely won't be longer than 11.
It will be either this length or shorter. I'm gonna try to cut it to make this length or shorter. That way it's an actual quiz and then it's doable in class. Okay, find the derivative of each function, right answer simplified form. So this is only 3.6, 3.7.
E prime plus b times u prime.
So
Let me learn.
think in your head, what do we need to do? Turn to the person next to you. What rule should we use?
The product rule.
Wow, that was great. Okay, because I have 4x times tan of 2x. So I'm going to have u be my 4x. What is the derivative of 4x?
I'm gonna say 4.
4.
I believe so.
So I gave this to you guys at least a couple days ago. You had time to try it if you haven't already. Otherwise, I'm gonna try to like go at nice speed. I'm not gonna try to rush through it, but like we're gonna go lively pace. V is tan of 2x. What is the derivative of tan? Secant squared 2x and then times 2. So I'm just put that 2 in front
Oh.
because chain rule, right? Because derivative of tangent is secant squared, and then we have to multiply by the inside. Derivative of 2x is 2. And then I just
I thought for like tan,
wait, what?
I thought for tans and all that stuff, you just keep it
For cans?
tans.
Tans.
and all that.
We leave the inside, so that's why I have secant squared of 2x.
But isn't it like attached to it, so it's not the chain rule?
It's inside. Tangent, I'm taking tangent of a function. The function's 2x.
But then, oh sorry.
Oh.
No. Go.
That's fine.
Your turn.
Can you like open up the secant of 2x? I don't really understand how that would
Okay.
Oh, okay.
Yes.
Why is it
Yeah,
that
me
you-
neither.
What is
You
it?
can
That was a
use
sheet that we had from
What?
I know that there was a sheet, but
tan is opposite. I mean,
So,
sine.
okay, I'll do this real quick. Tangent is sine over sine. Sine over cosine. Is that what I said? Sine over cosine. Okay, let's do quotient rule. Low, d high. Take high, d low. Low, d high. The derivative of the high is just cosine. Take high, d low. Derivative of cosine is negative sine. Cross the line, square the low. What's wrong?
Like, go figure out.
Why are we drawing attention to it? Okay. So I'm trying to figure out what the derivative is, okay? This is a side note. This is when I write, like, you could find it if you forget. This is how you do it. Y prime is equal to cosine squared x plus sine squared x all over cosine squared x. Pythagorean theorem. Cosine squared plus sine squared is 1. So this is 1 over cosine squared x, which is just secant squared x. Cool.
Yeah.
I see a lot of people writing, so I'm describing where this came from.
Oh.
So that's how I know tangent's derivative is secant. We derived it on the notes. So like these are the most like literally it's sine and cosine. I mean, tangent is an easier one to remember. So okay, now I can use my product rule. Okay. Product rule. U v prime plus v u prime. Yes.
Why would V1 equal that times 2x? Wouldn't it be 2?
Yeah, sorry. It's just 2. Sorry. Now just plug in. So, y prime. Okay, this was a little aside of how to find tan squared. So y prime is going to be u for x times v prime. So that's times 2 secant squared of 2x plus v tan of 2x times u prime, which is 4. So I can simplify this a little bit. Y prime is equal to 8x secant squared of 2x plus 4 times tan of 2x. Cuestiones. Preguntas.
So how come the 4x multiplies to the 2 and not to the 2x?
This?
Yeah.
The 2x that's inside. So you're taking secant of 2x. You can't pull the 2x in or out. Like you can't multiply it.
Why did the 4 go around though? Right. Because that looks like it's kind of on the outside.
It's to the front. It's the coefficient now. Okay, let's try the second one. Yeah. What am I going to use? Don't say it out loud. Don't say it out loud. Think to yourself. How should I solve? Number 2. which is the way you will start it. Now turn to the person next to you and say how you would do it. Oh, I heard everyone say it. I'm so proud. Quotient rule. Oh my gosh. Okay. Growth. I see growth happening. Okay. So, what? No, you're not.
I swear on my life, man.
Ah,
I couldn't even look.
they're talking smack. Okay.
Mr. Ryan, I swear on everything.
Peter up on that.
No, I swear.
What the heck? What the heck? No.
Quotient rule. What? Ready?
She's talking smack.
Quotient rule.
Cross the line and square the low.
Okay. Let's do it again. Ready?
Low, D high, to lie below. Cross the line and square the low.
Why are you looking at me like that?
That just sounded crazy. It sounded really confusing of what?
It's just B1
Yeah, it's just you do.
B1
Yeah.
over B squared.
Yeah.
Or just low, D high.
Like that song.
You guys like
makes
each
it
of you were
worse.
harmonizing, but like it just wasn't.
Okay. Whew. Low.
Oh my god.
Oh my god.
Low D high. Okay, so derivative of the high. Negative sine of 2x times 2. Take, so minus high D low, so cosine of 2x. What? What?
I don't know.
Is this what you wanted? Is that what you wanted?
No, like
Like the ones that you, like
Yeah.
1 plus u be 1.
Ah, yeah.
34.
Yeah.
I have a visual.
Yeah. High.
Make a raft.
Cosine 2x. D high. To negative 2. Shh. Focus. Focus. I moved your quiz so we could review together. Focus. Negative 2 sine of 2x. How did I do this? Well, derivative of cosine's negative sine. And then you gotta do chain, right? So derivative of 2x is 2. Derivative of 2x is 2.
No, it's good. I'm gonna remember this on the test.
Yes, that's the goal.
Good.
I don't care. I can make a fool of myself if you remember. Okay.
It helps me remember.
Low, 1 plus sine of x. D low, literally just cosine. Okay. Cross the line and square the low. Can we simplify this?
Yeah.
Can we?
By what?
Yeah?
Let me see. I will be the judge of that. You can't.
You can't. You can't simplify it.
So is that it?
So I'm going to rewrite it on the right side nicely. So over 1 plus sine of x squared. I need this whole line.
How many
Ugh.
points do we get if we like write out the whole thing like?
There's points associated for simplifying. There's points associated for like getting to this step though. So here's a hint. If you write out the formula for quotient rule, and you write out what u and v is, and the derivative of u, derivative of v, like, because then I see at least, okay, we did part of it right. Like, it's the number one god in my life, partial credit. That's what it is. Which is why you have to show your work. I say that 50 times a day. Show your work. Okay.
Sign. Get a shirt that says
Huh?
show your work.
Sine squared of x?
What?
Is d high is negative 2 sine squared of x?
Negative 2 sine 2x, sorry. Yeah. 1 plus sine x times negative 2 sine 2x minus cosine x cosine 2x. It's really hard to read. It's really small. I'm sorry. Well, all I did was rewrite it.
Do you care if the cosine's before or after?
What do you mean?
Like the cosine x before the cosine squared x?
No, multiplicative property of equality.
You
No,
need to
commutative,
do
commutative
that,
property
or
of
you don't
equality.
need to do it?
What?
You do need to
I'm
do
just-
the cosine?
It's an equivalent statement. If you have an equivalent statement, that's fine. Equivalent statement. If it's not equal, it's wrong. Okay, number 3. Number 3. So I'm gonna rewrite this. Make it a little simpler for ourselves, hopefully.
Negative 5
December
minus
2nd.
4x to the negative 1/2.
Wait, what second?
The Monday after Thanksgiving, the test. Because it's supposed to be before you leave, and now it's after you come back.
That's cool.
Wait, after? So, can we do it before?
No, Noah.
What?
You wanna study over Thanksgiving?
Actually, it's kind of true.
Yes, I would.
Yes, Noah.
I would love the extra time to look at my homework and look at my notes. And hopefully succeed on my test. Even though they don't care. What?
Aw, it's really sad.
It's really sad.
Okay, ready?
What's that?
Cha-chain rule. I mean, to a certain point.
I thought they didn't
I was
care.
raising my hand to drop
No
it.
one cares unless
I
like.
thought they didn't care. And I was
If
like,
you're like a nerd, they'll ask you for them, but like.
If you've been an A student, then I'll send you a drop to a D.
No, not a D.
Nah,
If you have like D's, if you like usually get A's, like get mostly D's, like you're not gonna care.
Right.
But like also they're not gonna ask for it unless like, you're deferred and like you want to see like. Or if it's like a hardware.
Alright.
But that's not.
I decided to not apply to
It's a true fact. Okay, let's go. Let's go. Chain rule. So bring down. Bring down the negative 1/2. And then 5 minus 4x to the negative 3/2. Multiplied by the derivative, which is negative 4. That's good. So the C minus sign cancels out. 1/2 of 4 is 2. So my derivative is going to be 2 over 5 minus 4x to the 3/2. If you're done with this one, try out 4. Let's get going. Let's get going. Try number 4.
What? That was a little small.
So I simplified the negative 1/2 and the negative 4 to 2. Move the rational, the negative, and the exponent to the bottom.
We're doing 4 now?
Yeah. If you're done, try out number 4. Let's see. 6 times 3x minus 7 to the 5th times 3. So it should just be 18.
18, 3, and
18 3x minus 7 to the 5th.
wait, don't say it. Oh my god, no one's helping me.
Cool.
Is there one like that on the test?
Quiz.
On the quiz, yeah, is there one like that? Can you just give us that?
Wait, am I dumb?
Wait, Janine, did you say it was hard?
No.
No, I.
Oh, was it hard for you?
If you're done with 4, try 5. If you're done with number 4, try number 5. Try number 5.
Oh, right.
Oh.
There's change.
Cosine.
I don't know about this one.
Oh,
Yep.
okay. See, when you have like a 4,
Wait.
This is what her question just was. What?
I think for tonight, if we were, are we gonna finish?
Oh, we're definitely not going to finish this because I keep having to wait and talk about Tall's whatever she was putting on and then like blah, blah, blah. I mean, the solutions for this have been up since before I gave you the quiz.
Oh, how come you? Oh, you can put the 4 there because it's just.
So I'm saying this is an equivalent statement so you can see the chain rule.
It has 3 layers.
Exactly, there are 3 layers.
That's right.
He's telling me it's 8. No, that's not
3 layers.
8 cosine times 2.
No, because you have to do the derivative.
Whoa there, Nelly. Whoa there, Nelly.
Let's try that.
8.
So the reason I wrote it this way is because sine is a smaller exponent than cosine. Cosine's to the 3rd power. Sine is to the 1st. Okay. If you're done with 5, try 6. Yes.
lot more complicated than it looked like at first.
I don't even know what to do.
Okay, so first thing I did was I cosine the fourth of 2x. I wrote it as cosine 2x to the fourth. So first,
Okay, wait, I have a question. So did you do the chain rule? Did you do 2 steps in the second problem?
so let me write this as like,
Because the sign, negative sign, and then the times 2.
so this is, so I'm going to try to color code so you can see. So negative sine of 2x comes from that part. And then the very inner part is right here. Maybe that's not different enough color. Okay, so hopefully you can see, like,
I get to
literally
there-
the chain.
If I get to there, how many points would I get?
What do you mean?
Would I get like 2, 1?
To this line right here?
Yeah.
I mean,
Because that's like the main problem.
that
I'd
is.
be confused.
And then you multiply 2 and negative 1 and 4 to be negative 8. Then you have sine 2x and cosine cubed of 2x.
What if I switched it? Because what if it was 8 cosine?
Negative 8 cosine cubed of 2x.
What if I got the answer?
Negative 1, 2, and 4.
But can you put it in front of the cosine?
Do you want me to write it this way instead?
Then 8 cosine. Okay, yeah.
This is the exact same thing.
Minus sine.
No, because this is this is multiplying by negative. I put the negative in front.
So it's not connected.
It's negative 1 times sine of 2x. So I multiply negative 1 by 4 by 2. Okay. Okay, and this is a... Sure.
Okay, so you're gonna do the product rule. So u is 2x minus 1 to the 4th, and the derivative of u is 4 times 2x minus 1 to the 3rd times 2.
Okay.
And then v is x plus 3 cubed. The derivative of v is 3 times x plus 3 squared times 4.
So that's fine. Cool.
And then you're gonna do u. Yeah. When you just plug it,
Yeah.
put the numbers.
Then you can't.
Times v prime, 3 times x plus 3.
Yeah, see, that's it. Is that it?
Close. Is there a common factor in both of these? 2x minus 1 to the 3rd. And I have a factor of x plus 3 to the 2nd. So I'm left with 2x minus 1 plus 8 times 2x minus 1.
Where does the 3 go?
Where the what 3?
In front of the x plus 3 squared.
Oh, wait. Oh, so sorry. This should be
Plus 3.
plus. Wait. Oh. Yeah. Sorry. Times 3. 2x minus 1 times 3 plus 8 times x plus 3. Yeah. Well, I mean, you can simplify it in here. You can simplify this. Okay, so class is over.
How do you do the problem below it? What is happening there?
Well, first derivative is sine, then it goes cosine, then it's negative sine, then it's negative cosine.
Isn't it negative sign because it's the third one?
So first, second, third, fourth, fifth, sixth, seventh, eighth. 1003 divided by 4 is, let's see, 250, and then remainder 3. So 1, 2, 3. This would be the derivative. Sorry, wait. 1, 2 should be negative cosine. Because this is, sorry. First derivative, second derivative, third, fourth derivative, fifth, sixth, 7. So it should be this one, remainder of 3. Okay, see you guys tomorrow.